that is based on some satellite. So if you want to, do away with GPS, depending on the GPS, and you want to make it GPS independent, then you need another reference point on which you can use, which is not necessarily based on satellites like a GPS. So you can use camera, which is a visual navigation system. So camera feed and camera inputs can be used to control the drone instead of being dependent on the GPS. In fact, camera feeds and camera inputs based on terrain maps that are already been done is a much more effective way of navigation, because it's a closed loop system that happens within the drone itself. So you can't interfere with it. So that answers also your EW question, because if I have cameras that are looking down and it has identified certain features on the ground, which is also there in a map, which is already there in it. That's the AI part of it, where it has got a map in it, and that map matches the feature, then it knows where it is. So it need not necessarily depend on the GPS for a reference. It can depend on the image that it has got for the reference. And based on that, when that navigation happens, it's difficult to interfere with that, essentially because it's something that's happening within the drone itself and without any external linkages. So whatever you do with it, you can't interfere with it.
Okay.
It is a closed loop system that's happening inside the drone.
All right. And for this, as I was asking before, the softwares and everything is basically written by you within the company.
Yes, it is written by us. Yes. It is completely written by us, and this is what is the core of our IP that we have, for which we have got a patent.
Okay, so that basically protects. You've also talked about motherboards, sir. So on your website you speak about Generation 5. I was researching some other places as well, where you've spoken about this motherboards quite often. What is special in them, sir?
See, what happens is you can use different kinds of processors. You could use a Generation 3 processor, you could use a Generation 5 processor. It's like, i3 is there, i5 is there, i7 is there. Now, these have different data computing speeds, and that's why the difference lies in the speed in which the computation happens. So the same way, now our lower generation autopilots were based on on much slower processor and older processors. The newer generation autopilots are based on newer processors and more advanced processors. Thereby, you can compute a lot more and at a much higher speed. So thereby, you can give corrections faster. So your navigation is much better. And you can also process more information. Like, for example, if you were to take, say, there is an old controller by the name of Atmega 328, which is a very, very old, controller that's been going, but it is a very rugged controller that is even being used today. It's a very good controller for the purpose of navigation. But when you get into computation like visual inertial navigation, and you require to do a lot of lot of more complex edged computing, then that processor falls short, and you'll need to go for a new generation of processors, like something like the STM32 and those kind of further generations, by which you can enhance the level of computing and the amount of computing that you do on board.